Hari Om. Today, let us proceed to the topic electrical potential energy of a system of point charges. So till now, what we have seen, we have calculated the electrical potential energy for a single point charge. So suppose let's start from a system which contains two charges. So suppose there are Q1 and Q2, and we want to calculate the electrical potential energy of this system, and the distance between them is R12. We will denote Rij as the distance between I and J. Alright, ith and jth charge. So R12 is the distance between R1 and 2. I am not considering vector quantities here because this is potential, electrical potential energy is not a vector quantity. Now, if you remember the definition of electrical potential energy, there we discussed that electrical potential energy is the work done in bringing a charge from infinite to a given position. So whatever work we do in bringing the charge from infinite to a certain position, that is our electrical potential energy. So just exactly let us apply the same concept. Now here we have two charges. That means initially there were no charges in this system, and from infinite we brought the first charge Q1 to this point. Do we need to do any work here? When Q1 was not there, there were no charges, there was no electric field, there was no potential. So potential was 0. Now if we bring a charge from infinite to this point, the work done is given by Q into V, charge into potential. When there was no charges, potential was 0, so the work done was 0. So our U1, that is potential energy due to 1, or work done in bringing the first charge from infinite is 0. Now work done in bringing the second charge from infinite. Now once this is there, the first charge is there, now if we bring the second charge, then due to the first charge, there will be some potential here. So there will be some potential V1. So the distance between them is R12. So now the work done will be, as you know, work done formula is charge into potential. So how much charge have we brought? Q2 into potential is due to V1. So Q2 into, now as you know, the potential of a point charge is K charge by distance. So V1 will be K. What is the source charge? Q1. And distance between them is R12. So this becomes K Q1 by R12. So the work done in bringing the second charge from infinite to this point will be K Q1 Q2 by R12. So now the total electric potential energy is the total work done. So 0 plus this is K Q1 Q2 by R12. This is the electrical potential energy for a system of two charges. Now let us proceed to a system of three charges. If we have three charges, then how much work we have to do and what will be the electrical potential energy. So we have three charges here, which are Q1, Q2 and Q3. Now as we started in the previous case, let us start from the first charge. So now in order to bring the first charge from infinite to some position without any other external agents, the work done will be 0, because now as you can see, clean board represents we don't have any charge or electric field or potential here. So the work done will be 0. So work done in bringing the first charge from infinite will be 0. So now we have placed our first charge here. Now due to this first charge, the work done to bring the second charge, suppose we want to place the second charge here, at a distance of r12 from the first charge. So now the work done in bringing the second charge in presence of first one, some work has to be done. So now, as you know, the potential is given by V1. So work done in bringing the second charge will be charge into potential. Now you should use these formulas always. Work done is charge into potential. Then potential of a point charge is K source charge by distance. So this will be K. What is the source charge of this potential? Q1 by distance between them is R12. So this is K Q1 Q2 by R12. Alright. Now the next important step. Now if we bring the third charge. So suppose we bring a third charge from infinite to this position. Now here, as you can see, two work dones will be there. Here, while bringing Q3 from infinite to this point, one work done will be because of Q1 and the other one will be because of Q2. So here, suppose this distance is R13 and this distance is R23. As we have already discussed, this is 13 means distance between 1 and 3, 23 means distance between 2 and 3. Let us consider the potential due to Q1 is V2 and potential due to Q2 is V3. So the work done in bringing the third charge, will be, work done is charge into potential, so charge is Q3 into V2 plus Q3 into V3. Try to imagine yourself, we have two charges here, both of them will be repelling Q3, so work done will be because of both of them, hence we have added both the work dones. When the second charge was brought, only one charge was there, so only one work done we have calculated. When the first charge was brought, no charges were there, so work done was 0. So now let us calculate this. V2 is potential due to Q1. So Q3 into, use this formula, K, what is the source charge? Q1, distance is R13 plus Q3 into K, here source charge is Q2 by R23. So this becomes K Q1 Q3 by R13 plus K Q2 Q3 by R23. So the total potential energy of this system will be addition of all the works. So total potential energy becomes K Q1 Q2 by R12 plus K Q1 Q3 by R13 plus K Q2 Q3 by R23. Now imagine if we consider 4 charges and we bring one more charge. So if we bring the fourth charge, there will be 3 work done for that fourth charge, because while bringing the fourth charge, some work needs to be done because of Q1, some work needs to be done because of Q2, some work needs to be done because of Q3. So work in bringing the fourth charge will be, suppose this distance is R34, this will be R24 and this will be R14. Let us consider that potential due to Q1 is V4, potential due to Q2 is V5 at this point, potential due to Q3 is V6. So work done in bringing the fourth charge from infinite to this point will be charge into potential, Q4 into V4 plus Q4 into V5 plus Q4 into V6. So Q4 into V4 is the potential due to first one. So K, source is Q1, distance is R14 plus Q4 into K, source is Q2 by R24 plus Q4 into K, V6 is potential due to Q3, So source is Q3 by R 34. So this becomes K Q1 Q4 by R14 plus K Q2 Q4 by R24 plus K Q3 Q4 by R34. This will be the work done in bringing the fourth charge. So the total potential energy of the system will be this much plus the fourth work done. And this will go on increasing like this if you bring more and more charges. But important is till 3 charges. I hope you have understood. Alright. So with this, let's stop here today. We will proceed to the next part in the next video. Thank you.